Okay, so the problems, these three problems here are a review of chapter 2. This is the chapter in which we learned how to graph linear equations and how to write equations of linear lines. And that's what these three questions are about: how to write the equations of several of the types of lines. Just as a review, remember, there are two important formulas that you have to know in terms of graphing lines. One is the slope formula, which we call M. And that's the formula. If you have 2 points on the line, you can do y2 minus y1 over x2 minus x1. You take the difference of the y's, that's your numerator, that's the top, and then you take the difference of the x's, that's your denominator, bottom, and that fraction is your slope. The other important equation that you have to know is the general equation for a line, which is y equals mx plus b, where m is the number in front of the x is the slope, and the b is what we call the y-intercept. So remembering those two things, the first question asks us to write the equation of a line where they're actually telling us what the slope is, and they're giving us one of the points that's going through. Now again, the standard equation for a line is y equals mx plus b. And the m, they already gave us. They gave us that m is 5. They told us the slope is 5. So putting that in, we get y equals 5x plus b. The only thing left to do is to figure out what is the b. And that I get by taking the point that they give me. It's not the y-intercept, because in a y-intercept, the x value would be 0. But it's just some point on the line. We stick it into the equation. Where I see the x, I'm going to put the -2. Where I see the y, I'm going to put the 3, which will give me then 3 equals 5 times -2 plus b. Now, solving this equation, it gives me 3 equals -10 plus b. And to get the b alone, I'm going to add 10 to both sides. So it turns out that the b turns out to be 13. If you were asked, what is the y-intercept of this line? You would have to say it's 13. But they didn't ask, they asked us for the equation of the line. So now we can write the equation of the line. Y equals 5x plus 13. When we're going to write equations of line, eventually we have to get something in the form y equals something times x plus something. That is the equation of the line. And the answer to this question would be y equals 5x plus 13. Okay, looking at question number 2, it says we want the equation of a line that passes through the point 2, 2. It's giving us again a point on the line, and it's telling us it's parallel to this line. Now we have to remember two things. When lines are parallel, put it over here. If the lines are parallel, then the slopes are equal. They're the same slopes. Parallel lines have exactly the same slope. Perpendicular lines have opposite reciprocal slopes. So the slopes are not the same when the lines are perpendicular. They are flipped over and opposite signs. So if, like, for example, if I have a slope here, the slope is 5, then the perpendicular line would have to be -1/5. You flip it over, this really means 5/1, and you switch its sign. If my original slope is -2/3, then the reciprocal line has a slope +3/2. You change the sign and you flip it over. Okay, well, this case, not asking us about perpendicular lines, they're asking us about parallel lines. So we know the line that we're going to write the equation of will have the same slope as this line, 2x plus 4y equals 7. The only thing is, this is not in the right setup so that I could see its slope. In order to figure out what its slope is, I have to put this in the y equals mx plus b form, which means I'm going to subtract 2x from both sides, which will give me 4y equals -2x plus 7. And then I don't want this 4 here, so I'm going to divide everything by 4, which will give me that the original line that they gave me is y equals, okay, -2/4 can be reduced to -1/2 x plus 7/4. And the important thing that we need to know now is the slope of this line, and that's the number that's in front of the x. Now, I couldn't do it over here. I couldn't say the slope is 2 here because it wasn't in the right setup. It wasn't the right format. Now that's in the right format, I know that the slope of this line is -1/2, which means my new line, what I'm gonna do is I'm gonna go up here. I'm going to erase this one because I just need the space. So now I'm ready to write the equation of my line. Why? Because I know the slope of my line. I now know what it is. It's -1/2. And I know the point that it's going through is 2, 2. So just like I did before, here's my new equation. Y equals -1/2 x plus b. I still don't know what the b is. It can't be 7/4 because I'm talking about a different line. This was my original line. The only thing that I need from the original line is its slope. Now I'm going to put 2 for the x and 2 for the y and see what happens. I'm going to get 2 equals -1/2 times 2 plus b. Well, when you multiply, and you could even do this on your calculator, -1 divided by 2 times 2. The 2's are going to cancel out, and that'll give me that 2 equals -1 plus b, because -1/2 times 2 is -1. I'll bring this 1 to the other side. That gives me that my new b is 3. The slope for my new line is -1/2 because it's parallel, but its y-intercept is 3. So here's my equation. Y equals -1/2 x plus 3. So you can't stop right here. This is the old line. We need the new line. Any question about this? Okay. So then let's look at this last question. We want the equation of a vertical line that passes through the point -7, 5. So I'm going to draw this because this is an easy picture to draw. Negative 7, 5 would be 7 to the left and 5 up, which is right here. Here's the point, negative 7, 5. Okay, we want the equation of a vertical line. Now, vertical lines, remember, are lines that go straight up and down. This is what that line looks like. Horizontal lines go straight across, vertical lines go straight up and down. And the equation for a vertical line is always just x equals a number. Very easy equation to write. X equals. So what does x equal? Well, I see what the x equals. The x equals the first, the x is always 7. My equation would be x equals 7. If I had wanted a horizontal line wasn't asked for that, but if I were asked to write the equation of the horizontal line, in other words, the one that goes this way, the equation of a horizontal line is also a very easy equation. It's always just y equals a number. So in a vertical line, you only have an x, there's no y in the equation. In a horizontal line, you only have a y without any x. So what's the y in this case? If I'm going through this point, I just look at the y value, the equation would be y equals 5. Again, the vertical line, the equation would be x equals negative 7. The horizontal line's equation would be y equals 5. Of course, there are other questions that could be asked on terms of lines, but this is the type of questions you should be prepared. You should be able to find the slope of the line, either by, if you're given the equation, by looking the number in front of the x, or if you're just giving points, you should find the slope using the formula. And then you fill in once you have the y equals mx plus b, once you've filled in the m, you go to find the b by putting in the point into the line. Don't forget, vertical lines always have just an equation x equal a number, and horizontal equation lines always have an equation y equals a number. Again, all of that is on the first page of the study guide. I hope you looked at it. I think it's a good idea to print it so you can, there are several other practice problems here. Again, not only did I give you the study guide, but I posted also the answer key so you can check your answers. So I basically reviewed chapter 2 on this page. On Friday, we will go over chapter 3. Okay. So now I'd like to go back to what we were talking about on Monday, which was the trigonometric functions. I'm glad to see there are more people here today. So I'll do a quick review of what we talked about on Monday, and then I'll just continue. There's just a little bit more that we have to say about trigonometry. So that's where we're going from here. Okay, I'm erasing this. And I'm going to leave that information on the board. Don't forget, the final exam is 2 weeks from tomorrow. It's on a Thursday. No, we usually don't have class on Thursday, but this is a departmental final, so therefore they did it according to the schedule for the departmental finals. It's specifically going to be, I'll have it set up. You're going to do it just like we did before on Blackboard, again, there is a practice final in the tests and quizzes section that you can do an unlimited number of times. It's good practice until you understand how to do each of the problems. The final will be on Blackboard, just like the midterm was, and just like the practice midterm and the practice finals. Also, the schedule over here is Patricia's tutoring schedule. This is in person in Medgar Evers in the Health and Science and Technology building, in room L00. On Thursday, she's going to be there between 2 and 4. On Friday, between 2 and 4. On Monday, between 12 and 2. And on Tuesday, between 1 and 4. And I think that's for the following week as well. So if you're having any particular difficulties and you need somebody to talk to you in person, you can always talk to Patrice. She definitely knows the material very well. Okay, so we're talking about the topic of trigonometry. And I even left that important note, SOHCAHTOA, on our board. And I'm going to go through a problem that has to do with trigonometry, with basically the parts that we have learned. So let's say I gave you a right triangle. Remember, we're talking about right triangle trigonometry, where they give me a picture of a triangle. And they're putting this symbol here, which is a Greek letter called theta. It's just the same thing like an X or an A, it's just a letter. Specifically, when they use Greek letters, they mean it's the name of an angle. So this is going to be called angle theta. And suppose they gave me that this side is 3 and this side is 8. And they asked me to find the sine of theta. Well, this is what we had basically learned last week. First of all, this SOHCAHTOA is telling us that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So we have these 3 important trigonometric values that we can find. One called the sine, one called the cosine, these are the abbreviations, and one called the tangent. And I'm using, you always have to put the name of the angle next to it so you know which angle you're looking at. We're looking at this angle right here. And each one of these 3 things is just a fraction. And it's a fraction that you get from the triangle. Now, that's what that SOHCAHTOA is reminding us. The sine fraction is the opposite side over the hypotenuse. The cosine fraction or ratio is the adjacent side over the hypotenuse. And the tangent fraction we get by doing the opposite side over the adjacent. So what do I mean by this opposite adjacent hypotenuse? So I go to my triangle and I look at my angle. The side that is directly across from the angle is called the opposite side. The side that is directly across from the right angle, that's the 90-degree angle, is called the hypotenuse. And that third side, the side that's attached to the angle, that's not the hypotenuse, the leg that's attached is called the adjacent side. So when I remember that, and we call it the mnemonic device, SOHCAHTOA, I know that sine, the SO stands for sine, is the opposite over the hypotenuse. That's what SO is telling us. It's hard to remember what goes with what. So, SOH means sine is opposite over hypotenuse. So if I want to find the sine of theta, I have to take the opposite side, which I know what it is, which is 3 over the hypotenuse, which I don't know. But if I want to find the sine, I need the hypotenuse. But I remember the very first thing we learned on right triangles is the Pythagorean theorem, a squared plus b squared equals c squared. Remember, here's my a, here's my b, here's my c. The c is always the hypotenuse. And I can always use, if I have two sides of the right triangle, I can always figure out the third side by using the Pythagorean theorem, sticking this in. It doesn't matter if you call this the A, this the A, or this the A, it doesn't really make a difference. The C is always at the hypotenuse. So it'll be 3 squared plus 8 squared equals c squared. 3 squared is 9. 8 squared is 64. So when I add 64 and 9, I get that c squared equals 73, which means that the c is the square root of 73. Because c squared, it's not c that's 73, it's c squared. The hypotenuse is the square root of 73. So now I can go further with this. I know now the opposite is 3, and the hypotenuse is the square root of 73. This is a correct answer, but usually we don't leave radicals in the denominator. What we do is we rationalize the denominator. So in order to do that, what we're going to do is multiply the top and the bottom by the square root of 73. So the top will become 3 radical 73. And the bottom will be the square root of 73 times the square root of 73, which is just 73. And this would be the answer that we would be expected to give. This is, by the way, this is the answer as an exact number. Sometimes they ask us to give the answer as a decimal. If they had asked for the answer as a decimal, I could only do that by using my calculator. How would I do that? I'd go back. I wouldn't even have to simplify it. I just take the 3 over the square root of 73, take my calculator, and therefore you must have a calculator, and do 3 divided by the square root of 73, which gives me 0.351. Usually they ask for 3 decimal places. The next decimal place is also 1, so I don't have to go round up. This would be my answer in decimal form. Again, you'll see which way they want the answer because you'll be able to look at the answers and see if they're in decimals or if they're in fraction or radical form. Okay, so I'm going to give you another problem to try. Okay. I'm going to give you time to try it on your own. Suppose I give you a problem that looks like this. I'm putting the theta over here. And suppose I tell you this is 9 and this is 5. And I want you to find the tangent of theta. I'm going to give you a few minutes to try it on your own. And I want the answer as in radical form, an exact answer. While you're doing that, I'm going to take a tangent. Okay, Emma, you're here. Isis, you're here. Jane, you're here. Carly, you're here. Kayla, you're here. Kiana, you're here. Ariana, you're here. Shania. Shania, have you here? Tatiana, you're here. Okay. Jean. There is the final exam is going to be on Thursday in 2 weeks. See, it says it, final exam, December 15th. That's a Thursday. No, there's no quiz tomorrow. No quiz tomorrow. There has been a quiz posted on Delta Math since before Thanksgiving. There is a practice final posted on Blackboard. It's on Blackboard and it's in the quizzes and tests section. You do it as many times as you want to. Your best mark will be counted as a quiz mark for the class. You have any questions, you can send me, either ask it or send me a text. Okay, so let's go to this problem. And we want to find the tangent of theta. Now, theta is up here. So let's look. We have SOHCAHTOA. So tangent stands for O, which is opposite, over A, which is adjacent. So I'm going to label my triangle that I have here. This is my right angle, because that's my square corner, according to opposite, adjacent, and hypotenuse. Now remember, I always look at where my angle is that they gave me. It's up here. Directly across from it is the opposite. In other words, sometimes this side is opposite, sometimes it's adjacent, depending on which angle you're asked to find the tangent or whatever function is they're asking you. So the 5 is the opposite. Across from the right angle is the hypotenuse. And the third side, the side that's attached to the angle, is the adjacent. Now, I go back to my tangent. I want my tangent to be the opposite over the adjacent. The opposite I have, it's 5, but I do not have the adjacent side. So just like we did before, we're going to have to use our Pythagorean theorem to find the third side of this triangle. So again, we're going to have to do a squared plus b squared equals c squared. And it's going to be 5 squared. It doesn't matter which you call the a and which you call the b. You have to make sure the c is always the hypotenuse. So I did 5 squared plus b squared, because I don't know what this is, equals 9 squared. So I have 25 plus b squared equals 81. And I subtract 25 from both sides. Remember, I have to subtract it. I don't do 5 squared plus 9 squared because it's always equal to the hypotenuse squared. And 81 minus 25 is 56. So therefore, the adjacent side, so b squared is 56. So b is the square root of 56. And actually, this could be simplified because if we 56, we could break it up into the square root of 4 and the square root of 14, which 4 being a perfect square becomes 2 radical 14. Remember how we did that? So this side is 2 square root of 14. And now we can find out, now that we have all 3 sides, now we can do the tangent, we can do any one. So they asked us to find the tangent, so I'm going to do opposite, which is 5, over adjacent, which is 2 square root of 14. And again, I want the exact value, but I want it with a rationalized denominator. So I'm going to multiply top and bottom by the square root of 14. Remember, you multiply by the radical. This is just one term. It's 2 times, so there's no plus in between it, so we don't use the conjugate. This becomes 5 radical 14. The square root of 14 times the square root of 14 just becomes plain 14. So I have to multiply the 2 times the 14, and that gives me 28. And that would be my answer in simplest radical. Okay, so that's basically a review of what we had learned the other day. I want to go one step further, and then we'll do some more problems. I'm going to erase this one. It's getting a little. The sine, and I'm just using the abbreviations, let's call it sine theta. The cosine and the tangent are what we call our primary trigonometric functions, or our primary trigonometric values. All we have to do in this course is know how to find them when we have a right triangle. When you go to 151 pre-calculus, most of pre-calculus is about trigonometry because there's so many things you could do. So we're just building the foundation so you know what these things stand for. As I said, these are the primary trigonometric functions. From SOHCAHTOA, we know that the sine is opposite over hypotenuse. I'm just using abbreviations. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. We explained what we mean by opposite adjacent hypotenuse when we look at our right triangle. That's why we always have to know what angle we're talking about so we can label our sides opposite adjacent hypotenuse. There are three secondary, and actually, if you look on your calculator, you'll see a button that says sine, cosine, and tangent. We're not using that because we're not actually working, we're not going far enough into our study of trigonometry that we need those buttons on the calculator. We just need the regular division and multiplication button. But there are three other trigonometric functions. They're called the secondary trigonometric functions. There's a function that's called cosecant, which is abbreviated CSC. I can't abbreviate it COS because that's abbreviation for cosine. So we abbreviated CSC. And the cosecant is the reciprocal. Each one of these is the reciprocal of one of the others. The cosecant is the reciprocal of the sine. In other words, the cosecant is the hypotenuse over the opposite. We'll do this with specific numbers in a few minutes. But if you can find the sine and you have the fraction that's the sine, all you have to do to find the cosecant is to flip it over. It's a reciprocal. The second of these secondary ones, so to speak, is something called the secant. It's abbreviated SEC. So we have the secant of theta. And it's the reciprocal of the cosine. In other words, it's the hypotenuse over the adjacent. And the third of these secondary ones is something called the cotangent. And it's abbreviated COT. So the only one that has a strange abbreviation that's not just the first letters is the cosecant for the obvious reason. Okay, the cotangent, as you guessed, is the reciprocal of the tangent. In other words, it's the adjacent over the opposite. How are you going to remember this? We finally remembered SOHCAHTOA. So SOHCAHTOA we know is sine opposite over adjacent. Sine is opposite over hypotenuse, etc. So how are we going to remember these other three without racking our brain too much? Well, if you think about it, I don't think anybody's going to have trouble remembering the cotangent. It sounds like it should go with the tangent, and it does. The cotangent is the reciprocal of the tangent. So the hard ones are the cosecant and the secant. And here's how I remember it. If you notice, each one of these, of the other two, one starts with an S, one starts with a C. The sine starts with S, the cosine starts with C. In the secondary one, they also have one that starts with S and one that starts with C. One is the cosecant, one is the secant. And notice the pair always, if one's in each pair, the sine pairs up with the cosecant, because if the sine that starts with an S, its pair has to start with C. In other words, you don't have two S's together, you don't have two C's together. So if they ask you about cosecant, I know it has to go with sine because it starts with C, so the other one has to start with S. Or if I talk about secant, I know secant is reciprocal of cosine because secant starts with S, its pair has to start with C. So I think that's a way of remembering it so that you have all of them put together. So how do we do a question that has to do with so I'm gonna give you an example. You have this triangle. Let's call this our angle theta. Usually, if I don't, I usually put the theta over here, but sometimes they put it over here, but this time they put it over here. And they gave us this side to be 30, this side to be 34. And they asked me to find the cotangent of theta. And they give me, here are the choices. They actually rounded to the nearest tenth. Most of the times they round to the nearest 3 digits, nearest thousands, but this time they rounded to the nearest tenth. Okay, so these are the 4 answers they gave us. Which one of these is the values is the one that's closest to the cotangent of theta? I'm going to give you a few minutes to try it, and then we'll do it together. If you have an answer, put it on the chat. Okay, I think we should work on this together. Okay, so the first thing is, it asked me to find the cotangent of theta. And the first thing I always do is when I have my triangle, and if they just describe the triangle, I draw the triangle. I write what's the opposite, what's the adjacent, what's the hypotenuse. So here's my theta, here's my opposite side, here's my hypotenuse, and here, of course, then is my adjacent. And the cotangent, we know what we're going to do is first is the reciprocal of the tangent. So here's what I'm going to do. I'm going to figure out what the tangent of theta is, and then I'll flip it over and that'll give me what the cotangent is. So the tangent of theta is TOA, is opposite over adjacent, O over A, TOA. So tangent is opposite over adjacent. And in this triangle, I have the hypotenuse and the adjacent, and I don't have the opposite. So again, I have to do my A squared plus B squared equals C squared. So I'll do A squared plus 30 squared. Remember, it always has to equal the hypotenuse squared, 34 squared. And I certainly want to use my calculator with these numbers. So I'll get, going over here, I have A squared plus 30 squared is 900 equals 34 squared. So 34 squared is 1,156. So I'll subtract the 900 from both sides, which gives me A squared equals, I'm subtracting 900 on my calculator, 256. And I'm not so familiar with that, so I'm going to try, is that the square root? Is that a perfect square? So I'm going to do the square root of 256 and see what happens. And guess what? It comes out to be the number 16. It is a perfect square. If it doesn't come out to a perfect square, then I know I have to simplify the radical. But I didn't have to. This turned out to be the plain number 16. So now we can do the problem. We know that the tangent of theta is going to be opposite over adjacent, TOA, 16 over 30. So the cotangent is going to be just the opposite of the reciprocal of that. It's going to be 30 over 16. And I'm going to stick that into my calculator because they want it in decimal form. They didn't say give it as a fraction form. They want it in decimal form. So I'm going to do 30 divided by 16. and it comes out to 1.875. And that rounds off to 1.9, which was choice A. I hope some people got choice A. So using the secant, the cosecant, or the cotangent is basically the same thing as SOHCAHTOA, except you have to do one extra step. You have to take the reciprocal. Okay, so I'm going to let's do one more question like this, and then we'll start a new topic. I'm going to leave that on the board for now so we can have it as a reference. And let's say I gave you a question like this. Suppose I told you that the cosine of A is 2/3. And I want you to figure out the cosecant of A. I'm going to do this one, and then I'm going to give you one to try. Okay. Now, I know whenever they talk about a sine or a cosine or tangent, it has to do with the right triangle. So the first thing I'm going to do is draw myself a right triangle. And I'll put my A over here. It doesn't matter where I put it. The C always has to go by the right angle, by the square corner. Now to say, this is going to be my small a, this is going to be my small b, this is my small c. And in terms of A, this is the opposite side. Remember, when I'm doing trigonometry, that's the first thing I do. I write opposite, I draw my triangle and put in these numbers, these symbols. Opposite, hypotenuse, it's across from the right angle, and this is adjacent because it's next to the angle A. And we know that the cosine is adjacent over hypotenuse. So if they tell me the cosine of A is 2/3, essentially they're telling me that they've given me the cosine. They told me two sides. They told me that the adjacent side is 2 and the hypotenuse is 3. So just giving us one of the trigonometric values actually gives us two sides of the right triangle, because each of the functions always is a ratio of two sides. So I know one side, the adjacent side is going to be 2, hypotenuse is going to be 3, which means that I can always figure out the third side by doing a squared plus 2 squared equals 3 squared. So that'll give me a squared plus 4 equals 9, and I'll subtract 4 from both sides. That'll give me a squared equals 5, which means a is the square root of 5. So now I've got my whole triangle set up. I can figure out any of them. I want to find the cosecant. Well, I know the cosecant partners with the sine. The sine is so. The sine is opposite over hypotenuse. And in our triangle, the opposite side is square root of 5. And the hypotenuse is 3. That's not the one that I want, though. This is the sine. The cosecant, then, is its reciprocal, 3 over the square root of 5. And if they want it as an exact value with a rationalized denominator, I'm going to have to multiply it by radical 5 over radical 5, which will give me 3 radical 5 over 5 as my answer. So again, it's always one step more than the primary. Find the primary and then I just flip it over. And then I simplify. Let's see what I can find. Another problem to give you. Okay, here's a question for you now. Now that we did one, I'm going to give you one to try. Suppose I give you that the tangent of theta is 3 over 4, and I ask you to find the secant of theta. Okay, I'm giving you a few minutes to try that. Anybody have an answer? Okay, I think we should do it together. Okay, again. As soon as I see sine, cosine, tangent, cotangent, anything like that, I know I've got to make a right triangle. Sometimes they give me the right triangle, sometimes they didn't. In this case, they didn't. And I have to put my angle theta. If they don't tell me where to put it, I always put it on the bottom here. And since I'm putting it over here, I'm labeling, this is my opposite. This is my adjacent. This is my hypotenuse. We've done this enough times, so I think we know. Now the tangent we know is opposite TOA, opposite over adjacent. So that means the opposite side is going to be 3, and the adjacent side is going to be 4. So we have 2 sides of the right triangle. Let's see if we can find the third side. Well, we have the a squared plus b squared equals c squared. So it's 3 squared plus 4 squared equals c squared. And we get 9 plus 16, which is 25, is c squared. So C, our hypotenuse, has to be equal to 5. Very nicely came out to be a rational number. Okay. Now that we have all 3 sides of the triangle, we can figure out any one of these trigonometric functions. They're asking us for the secant. Now I remember the secant partners with, partners with cosine. And cosine is cot adjacent over hypotenuse. So the cosine would be 4 over 5. So the secant then has to be its reciprocal, which is 5 over 4. So just that one little extra step to get the secant. And if you wanted it as a decimal, then you would just take your calculator and divide the numerator by the denominator on your calculator. You'd get 0.8 if you want to do it that way. But usually they want it as a fraction. Okay, so that's what we have to know about trigonometry. We have to know how to find, well, the Pythagorean theorem, which is really not part of trigonometry, but it is certainly about right triangles. You have to be able, if you know any 2 sides of the right triangle, to figure out the third side, number 1. And then you have to be able to, you have to know that SOHCAHTOA, the sine is opposite over hypotenuse, the cosine adjacent over hypotenuse, the tangent opposite over adjacent. And then you have to know the secondary ones. The cosecant is the reciprocal of the sine, the secant is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. And all you're required for this course is to be able to figure out what they are. Now, obviously, there's some use to this, and we haven't talked about what applications, how is this helpful? What do we do with this? That's part of your next course. Okay, so we're now going to be starting our last chapter, which is chapter 8 in the book. Okay, this was not in the book. This is what you have to know. Again, a good review of it is on your practice, your study guide sheet, which has all the important information. Remember, this is you with some different examples for you to try. It's on the study guide is posted on the Blackboard section of information. In the information section, you can go and see your study guide. And again, it's not just the important formulas, it's also given examples and there's an answer key with the examples. Very good review of the course. So we're up to our last chapter. And the topic of the last chapter is exponential and logarithmic functions. And I think it's obvious that from the name that this has something to do with exponents. So before we even start that chapter, we better do a review of how to work with exponents and all the basic rules that go with working with exponents. And once we are pretty clear on how to work with exponents, then we can go on and talk about these exponential equations, which are equations where we have x's in the exponent, and something called logarithms, which I can't even explain what it is until I teach it. But let's talk about exponents. So let's say I have x to the fifth, and I'm multiplying it by x to the fourth. What do we do when we're multiplying? First of all, the x in this case is what we call the base. The superscript, little raised number, is the exponent. And if I see x to the fifth, of course, you know it means that you're multiplying x 5 times. In other words, if I would do 2 to the third power, you would know it means 2 times 2 times 2, which is, if you figure it out, is 8. So this is 3 as an exponent, and it tells you how many times you're multiplying the number by itself. The number that has the exponent is called the base, and this number is the exponent or the power. So when you're multiplying two numbers that have the same base, but they have, then what you can work with the exponents and just add the exponents. In other words, x to the fifth times x to the fourth is x to the ninth. If you have x to the ninth divided by x to the third, for example, when you are dividing two numbers that have the same base, then what you do to their exponents is you don't divide the exponents, you subtract the exponents. You get x to the sixth. And when you have, let's say, x squared, and you raise it to the fifth power. Let's say you have something that's starting out with an exponent, like x squared, and you put a second exponent on it. What you do to those two exponents is you multiply, because this really means that you're multiplying x squared 5 times, you're getting x to the 10th. If you have two numbers like this, suppose you have x to the second, y to the third multiplied, with two numbers with different bases written, and you raise that, let's say, to the fourth power. In other words, you have an expression that's the product of two different numbers, the bases are different, and together they have an exponent. What you do is you distribute that exponent to both of the numbers. In other words, you're going to do the 2 to the x squared to the 4th, which will give you x to the 8th, and the y cubed to the 4th, which will give you y to the 12th. And similarly, if you have a fraction, let's say you have x to the 5th over y to the 3rd, and that's raised to the 4th power. Again, you're going to distribute, you're going to put the x, if it's a parentheses around the whole thing, you're going to do the x 5th to the 4th, which will give you x to the 20. And this will give you over y to the 12. Now you can't subtract the exponents here because your bases are different. But those are the basic rules of exponents. And I'm sure you know these rules from prior. If not, these are the basic rules. Now, what kind of numbers can be exponents? Let's talk about that. So, most of the time, the type of exponent I have on is a whole number, a regular positive whole number, what we call a natural number, a positive integer. That's the most common, that's how we define. So if I have something like x to the 5th, it means multiply x by itself 5 times. But it's also possible to have an exponent of 0. And an exponent of 0 is defined, anything with the exponent of 0, doesn't matter what the base is always 1. So if I give you x to the 75th power raised to the 0 power, which would give you, of course, when you multiply the 75 times the 0 is x to the 0, that's for sure going to be 1. So anything to the 0 power is equal to 1. What about something that has a negative exponent? It is possible to have a negative exponent as well. For example, I could write something like x to the negative 3. And what that means doesn't mean you're multiplying x negative 3 times, because that doesn't make sense. It means put 1 over your number and make the exponent positive. In other words, the negative exponent is telling you to take the reciprocal of the number. Flip it, if it's in the bottom, put it on top. If it's on the top, put them on the bottom. That's what you do when you have a negative exponent. So, for example, if I were to give you something like this, x third, y fifth over z to the 7th power, and I put that all to the negative 3 exponent. I'll tell you how I find is the easiest way to deal with this. You know what, let me make one of these negative also so I can show you. Suppose I have x third, y to the negative 5 over z to the 7th, and that whole thing is being raised to the negative 3 exponent. Now, all the rules that I told you about before that have to do with exponents when you have two numbers with the same base and you're multiplying them, you add the exponents, etc. And if you have an exponent on the outside, you distribute it, etc. That all works, even if the exponents are negative exponents. So when I have an expression with a negative exponent on the outside, or with any exponent on the outside, the first thing I do is I distribute that exponent to each of the variables. So first I'll do the x3 to the -3, which will give me x to the -9. Then I'll do the y -5 to the -3, and -5 times -3 will give me y to the +15. And z to the 7th to the -3, I have to do everything because it's in a parentheses, is going to give me z to the -21. So first step in simplifying these complicated expressions with exponents is to get rid of the parentheses by distributing your exponent. Here's the next thing that I think makes it easiest to deal with. Once you have everything individual, you look at each letter and think, is its exponent positive or is its exponent negative? If its exponent is positive, leave that expression right where it is, because you don't have to take the reciprocal. But if the exponent is negative, it's telling you to take its reciprocal. Well, how do you take the reciprocal of anything? If it's already in a fraction, anything that's in the numerator will go to the denominator. And if it's in the denominator and you want to take its reciprocal, you're going to move it to the numerator. So here's what I'm going to do. Here's my fraction. And if there is no fraction line, make a fraction line and put it over 1 because you want it to be a fraction. The x to the -9 is going to go to the denominator because I have to take its reciprocal. The y to the 15 is going to stay on top because it doesn't have a negative exponent. It stays where it is. And the z to the -21, that goes, it's in the denominator, it's in the bottom, it has to get moved to the top because that's how you take the reciprocal. Anything on top goes to the bottom, anything on bottom goes to the top. And there's nothing more that you can simplify because there are no like bases. This is your answer. In other words, you don't want to leave your answer with negative exponents. You want to leave them only with positive exponents. So move anything that has a negative exponent. If it's on top, move it to the bottom. If it's on the bottom, move it to the top. If it has a positive exponent, just leave it where it is. See if I can find a problem for you to do. Okay, so here I'm going to write a problem on the board. I'm going to give it as a multiple choice. Okay, it's telling me to simplify with leaving only positive exponents. I'm going to give you the choices and then we'll discuss it in a minute. And I know I'm not giving you much time, but we only have a few minutes, so I'm going to do this together with you. First of all, I have something to a -2 exponent. So the first thing is I want to get rid of that parentheses by distributing the -2 to each of the letters and numbers. Now notice -3 also has to have, it doesn't have any exponent, the -3. That means that the -3 is to the -2 power. Then we do the x squared to the -2 power, which will give us x -4. Then we'll do y, which is really y to the 1 to the -2 power, which is y to the -2. And finally, z to the -1 power to -2 becomes z to the +2. Okay. So I've distributed it, and don't forget, if there's a coefficient, that really is accepted as a 1 as its exponent, and it also has to be done to that exponent. Now, we're going to start moving things. Remember I told you, I said make a fraction line. Basically, everything here is on top, so there was no fraction line, but it was really over 1. So this -3 to the -2 will become -3 to the +2 in the denominator. The x to the -4 will also have to go to the denominator and become an x to the 4th. The y to the -2 will go down and become y squared. But the z squared have to stay on top because its exponent is positive. And the only thing I have to do is figure out what this number is. -3 squared means -3 times -3, which is 9. So my answer becomes z squared over 9x fourth y squared, which is choice B. Be careful. The 9 had to go, the -3 squared had to get, but that had to go in the denominator because it had a negative exponent. But when you multiply -3 times a -3, it becomes positive. It is not negative. Okay, so here's where we're going to start off next time. We're going to talk about fractional exponents, and then we're going to talk about exponents in general. Okay, have a good day, everybody. If there's no questions, I'm going to end the class for everybody.